Now, lecture 2, tangent plane. Differentials from point Q, with a fantasy, to point P, with a label. You see? Now, from lecture 1, I just swap this case. This is a polar coordinate and theta is the azimuthal coordinate. That's written over here. R is the radius. You see, this is a surface. The manifold consists of a surface of unit surface. The radius is 1. You see, that's capital X1, X2, and X3. Okay, exactly the same notation we used in the previous lecture, lecture 1. So point P, you see, small x, X1, X2, X3, this is just labels. Okay, then I set at P a Cartesian coordinates. You see, X1, capital X1, X2, X3. Exactly what we did in the previous lecture, lecture 1. So these are the coordinates. I just swap. In this case, theta is azimuthal, phi is polar, and r is the radius, which is 1. Okay, this is the radius. In this case, this is said to be 1, the unit. Now, point Q, you see, capital X, 1, 2, 3. These are, in this case, Cartesian coordinates, okay? X1, X2, and X3. And then I choose a fantasy, okay, which consists of angle phi and theta. This R is 1, R sine phi sine theta, and R cosine phi. R is 1. You see, you remember from lecture 1, okay, the point is theta is equal pi over 3, and phi is pi over 2. Just from lecture 1, R is equal 1. So there's a point Q, okay? I just substitute, okay, theta and phi, and this over here, you see? This is X1, X2, and X3. I just substitute here for R is equal 1. This leads to point Q, square root of 3 divided by 2, 1/2, and 0. That's a point P. That's a label, okay? Point P. Q is a fantasy, okay? I could, for instance, set sine square of phi, cosine, tangent of theta, doesn't matter, you see? I choose the fantasy. In this case, my fantasy is exactly the coordinates of the sphere coordinates, okay? Now, this is a point Q, and the previous lecture I just swapped. This I think is 1/2 square root of 2 and 0. But this I'm working with phi as a polar and theta is azimuthal. That's why I swap here square root of 3 divided by 2, 1/2, and 0. That's identical. Q and P, they are the same point, okay? But I'm working now, all the calculations are done on the fantasy, okay? That's important here. Not at P. I can't. Point P is a point of the manifold, is a label. I can't do any operation, okay, on P. That's why I work on a fantasy, okay? So these differentials from Q to P, the calculation of this differential, okay, are done, okay, in the fantasy, not at P. Now, then the space, this is fantasy here, okay, that's old pH is the old way, okay, this is FA, here, okay. So the space, the fantasy here, R2 is 1, 1, 1, 1, U1 and U2. Exactly the same notation as we did in lecture 1. So point Q is P, in this case, pi over 3 and pi over 2. This is U2 is the phi direction, and U1 is a theta direction, okay? So this is a point Q, which it is coincide with point Q. But I'm working here on the fantasy. All the calculation, I insist in saying that all the calculation, they cannot happen at point P. They always happen at point Q, which is a fantasy. So recall that Q was obtained from M3 to R2. This notation here is analogous. For instance, you have in calculus X, Y, and Y over X. You see, this from X to Y over X, okay? X is independent variable, okay? And Y is the dependent variable. So when I write M3 to R, okay, this behaves like X. So the variables on M, okay, they are, in this case, they are independent, and R2 are the dependent variable. That's analogous to calculus, see? Now, important remark here. To obtain differentials at P belongs to M3, we must, you see, let's mark over here, see what's important. See, we must map them from R2 to M3. You see, this case R2 will be the independent variable and M3 will be the dependent variable. That's important, this mark over here. So differential at point P belongs to M3. Now, you see, all the calculation, they must be done on the fantasy, you see? So dx1, differential dx1, partial x1 with respect to theta, this d theta x1 phi d phi, which is quite easy just to substitute over here. This is x1. I take derivative respect to theta and derivative respect to phi, r is equal 1. I just write over here, just clear. So this is minus sine phi, sine theta, d theta, plus cosine phi, cosine theta, d phi. You see, this I take the partial derivative. I just look at x1 and do these partial derivatives. Okay, the same, dx2 is partial x2 respect to theta, d theta, partial x2 respect to phi, d phi. Again, I look at x2, r is equal 1, and just take the partial derivative, okay, which is clear. So I can write this and substitute the point. Attention now, you substitute the point Q in this case. I just substitute in this case. You see, you have phi here is pi over 2 and theta is pi over 3. I just substitute over there and make this calculation. Again, all the calculations are done on the fantasy, you see, not on the manifold. So this clearly, you just copy here, this 1/2 d theta, and dx3, again, partial x3 respect to theta d theta, partial x3 respect to phi d phi. R is 1. Now I look at here, you see, r cosine phi, it is x3. R is 1. You just take this derivative here, the x3. This comes to the minus this d phi. Quite clear, just substitute. Then remember that phi is pi over 2 and theta is pi over 3. You just apply, get calculate the trigonometry, cosine and sine. This is clear. Now, I can represent as a matrix. You see, dx1, dx2, dx3 is a matrix 3 by 1, okay? 3 rows and 1 column. And this is 3 rows and 2 columns, d theta dt. You see, I just look at here clearly and I can represent dx1, dx2, dx3, the column, okay? Column vector. This is a matrix, okay? Not square matrix. And this is d theta and d phi. You see, you just multiply here and you obtain exactly this derivation. Attention now, all this derivation, dx1, dx2, dx3, they are done, okay? In this case, then I'm moving, okay, from R2 to M. So this at P, that's important here, this at P is calculated, attention, is calculated on the fantasy, and the result comes to the P, okay? Likewise, this P over here. So it's clear. Now that's the figure here. This is phi pi over 2, okay, the polar coordinates. This pi over 3, that's point P, okay? So then I substitute, you see, I did all this calculation over here, okay? Then I substitute this, what I calculated, I just substitute over here. This will be just copy from here and you set right over here. So minus square root of 2, 1/2 and 0. This 0, 0 and minus 1. If you multiply this, okay, there's a matrix. This is, in this case, is 3 by 2. This is 2 by 1. You see the matrix, 2 by 2. This will be 3 by 1. You see? So this here is a tangent vector. Okay? If I plug this on here, you see clearly, attention now, this vector here, the tangent vector, you see is pointing in this direction. You see the projection on x1 is negative, okay? And the projection on x2 is positive. You see clear here, see? The projection on